So in this section, we'll talk about how to determine whether a function is one-to-one, how to find the graph of an inverse function from the graph of a one-to-one function, how to verify if two functions are inverses, and then find the inverse of a function. So it's still the 21st of January. It's crazy. Can't believe January is almost over already. All right, so one-to-one functions. What is a one-to-one function? We say a function is one-to-one sometimes you'll see one-to-one abbreviated like this, guys. 1-1, 1, 2, 1. If any two different inputs in the domain correspond to two different outputs in the range. Remember, guys, inputs, what variable is that? X, and so your outputs are Y. So two different X's give you two different Y's. That means for any 2 points, X1, X1 and X2 in the domain, F is one-to-one if f of x1 does not equal f of x2. So the y values, if these are different numbers, when I plug them into my function, the y values cannot be the same. A function is not one-to-one if two different inputs correspond to the same output. You guys will see an example of that right now. So the way that we talked about it in Math 3, and then also last semester, is the way that we can prove it is by using the horizontal line test. Is everybody good on the first box? Okay. It's like the nods and overwhelming silence as a yes. Horizontal line test, if you guys want to ever abbreviate it, I'm okay if you guys abbreviate it as capital HLT. Why? Because we're lazy. That's okay. Horizontal line test. If every horizontal line intersects the graph of a function f in at most, highlight or underline that, at most 1 point, then we say that f is one-to-one. All right. So quick example, and then we'll pause until tomorrow. So use the graphs to determine if the function is one-to-one. So don't feel like you guys have to bust out graph paper right now. What shape is x squared? A U. It's a quadratic function. Good. So let's just draw a graph that is U-shaped. That crosses 0, 0. So something like that. Are we happy with that? No one's going to yell at me that it's not perfect. Okay, good. All right. Draw a horizontal line through the graph. And ask yourself, how many times does this red line touch the purple graph? 2. For this test, how many times do we want it to touch? Once. So does this pass the test if it passes or crosses twice? No, it fails. So this fails the horizontal line test. So what's our conclusion? Yes, so f of x, therefore, f of x is not. Oh, g of x, thank you. I'm looking at my notes from last year. G of x is not 1 to 1. Sometimes I change things. I just wasn't paying attention, sorry. All right, B. Do you guys remember what shape x cubed is? It's like an S, right? A little snake. So again, don't beat yourselves up if this is not perfect, but it should look something like that. So we're running out of time. Sorry, guys. Oh my goodness, it only crosses once. How exciting. So therefore what? Yes, h of x is 1 to 1. And we will pause there until tomorrow. Okay, so for inverse functions, yesterday we were reminded of what the idea was and what it meant for a function to be 1 to 1. Thank you. So if a function f is 1 to 1, so if f is 1 to 1, then it has an inverse function denoted y is equal to f inverse of x. The graph of an inverse function and the original function are symmetric across the line y is equal to x. This is an important property because this means a couple things. This means that the domain of f is the same as the range of f inverse, and the domain of f inverse is the same thing as the range of f. So what this tells us is that for the two functions, the domains and ranges switch. So if there's anything you guys take away from this lesson, please don't forget this idea. The domains and ranges switch. Okay? If you guys remember in last semester, you guys were taught how to prove when two functions are inverses by doing the composition. So remember that means that f of f inverse of x is equal to x, and f inverse of f of x is equal to x. Okay, you have to prove both directions. Okay, so the next problem we're going to do is you guys should have a graph. Is everybody good on this box? Okay. So if you know a graph of a function, to know if it has an inverse, so spoiler alert, it does. But in order to know if it has an inverse, remember it has to be 1-to-1. In order for it to be 1-to-1, remember it must pass what test? Horizontal line test. If I draw a horizontal line anywhere on this graph, guys, is it going to touch the graph twice? No. So this function does have an inverse. Okay. We just learned that for inverse functions compared to the original function, remember the domain and range switch. So all you have to do to sketch the inverse function is switch the x's and y's. So instead of graphing the point -2, -1, I'm going to graph the point -1, -2. So somewhere right here. Instead of graphing -1, 0, I'm going to graph 0, -1. And then I'm also going to graph 1, 2. So our inverse graph looks something like this. Okay, so this was 0, -1. This was -1, -2. And this is the point 1, 2. And then just remember, it's symmetric across the line y equals x. Y equals x is a perfectly diagonal line that goes through 0, 0. So most of the time it's easy to tell by looking at this, but can you guys tell if I folded the graph across this red line, it would line up on the other points? Can you guys see? So looks like we did this correctly. Okay, questions on this one? Okay. I don't want to torture you guys too much because you guys have already seen what inverses are. So I'm just going to remind you guys how to do this. So we're only going to do a couple more problems because I'm assuming that you guys didn't forget everything from last semester, right? Hopefully not. So how do you prove that they're inverses? So we're going to do a part A and a part B. So verify that f of x is equal to 2x plus 3 and f inverse of x is equal to 1/2 times x minus 3 are inverses. So remember, that means that we have to show that f of f inverse of x is equal to x and f inverse of f of x is equal to x. So it doesn't matter where you start. I'm going to start with this direction. So f of f inverse of x is equal to f of, in the parentheses, I want us to replace this with the function f inverse of x. So f inverse of x, they told us, was this, 1/2 times x minus 3. Okay, so remember that means that wherever I see an x in f, I'm replacing it with the inverse function. So this is going to replace that. So this will equal 2 times 1/2 times x minus 3 plus 3. Is everybody cool with where that came from? All right, so before we get too crazy and distribute this and make it a mess, what's 2 times 1/2? It's just 1, right? So this will cancel with the 2. So that just leaves me with the parentheses x minus 3 and then plus 3, which simplifies to x. Okay. Doing the other direction. So we want to show that f inverse of f of x is equal to x. So that's going to be the same thing as f inverse of, inside the parentheses, I'm going to replace this with what f of x was. So f of x, they told us, was 2x plus 3. So this is going to replace the x in the inverse function. Is everybody cool with that? So this will equal 1/2 times, I'm replacing it with the 2x plus 3, and then we also have the minus 3, so I need to include that, so minus 3. Okay, combine like terms, the positive 3 and negative 3 just cancel out. So I'm left with just 1/2 times 2x, which is just x. Okay, you can write a conclusion if you want. As long as you prove it, I'm happy. Okay, because that tells me that you guys know what you're doing. Okay, questions? All right, so let's do another one like this. So let's make it a little bit harder. So B, verify that f of x is equal to 1 over x minus 1, and f inverse of x is equal to 1 over x plus 1 are inverses. And then I'm going to add a follow-up question. For what values of x is f of f inverse of x equal to x, and f inverse of f of x equal to x? Okay, so this is a new part to this semester. So we're going to verify first, and then we'll deal with this follow-up question. Okay. So let's prove the forward direction first. So f of f inverse of x is equal to f of, I'm going to replace the parentheses with what the inverse was. So 1 over x plus 1. So all of this is going to replace the x in f of x. So this is going to look really ugly at first because we're going to have fractions inside of fractions. So this is going to be 1 over, do you guys agree it's going to be 1 over x plus 1 and then minus 1? Does that make sense? Okay, so before we cry a lot because this looks terrible, simplify. What's positive 1 minus 1? There's just 0, right? So those cancel. So we get 1 divided by 1 over x, okay? The way that we can simplify this is, remember, can't I rewrite this 1 as 1 over 1? So this is going to be 1 over 1. What's the rule for dividing a fraction? You multiply by the reciprocal. So times the reciprocal of the denominator, which is just x over 1. 1 times x is just x. 1 times 1 is just 1. I don't need to include a denominator of 1, so this is just x. Okay. For this question, for what values of x is f of f inverse of x equal to x? My question for you guys is, what's the only value? So you guys see how f is on the outside? What is the only value I can't plug into this function? 1. So you would answer this on your homework as x cannot equal 1. Okay, so now let's do the other direction. And I'm going to make this smaller so everything fits. So f inverse of f of x is equal to f inverse of f of x, they told us, was 1 over x minus 1. So I'm going to take this and plug it into x in the inverse function. So this will equal 1 over x minus 1 and then plus 1. Okay, this looks horrible, but remember, this is the same thing as 1 over 1. So multiply that by the reciprocal of the bottom, so that way we just get one fraction. So this will equal 1 over 1 times x minus 1 over 1, and then plus 1. 1 over 1, if you multiply something by 1, it doesn't change. Do I need this 1 anymore? So all of this, do you guys agree, is just x minus 1? What's x minus 1 plus 1? Just x. Okay, so that one wasn't too bad. Okay, so same idea. If I'm trying to figure out this question, what's the domain of this function? What's the only value I can't plug in? 0. So for this answer, you would just say x cannot equal 0. Okay? All right. All right, one more part, and then we're done with chapter 1. So how do you find an inverse function? Okay, so to find the inverse of a function, replace f of x with y. You guys remember what comes next? Switch x and y. What comes next? Solve. Good. Okay. Then we'll get y equals something, but remember we're finding an inverse. So you want to rewrite it. Rewrite your answer using the inverse notation, so f inverse of x. Okay. The last step, remember, is to verify that they're inverses. But I'll let you guys know, you only have to do this step if the question asks you. So if it doesn't tell you to do it, then don't worry about doing it, okay? Cool. All right. So you guys have done quite a bit of practice of this with different types of equations. So just to build on your skills, I'm going to do one like this, but with something we haven't done yet. So it's going to be a little bit harder. So given that f of x is equal to 2x plus 1 divided by x minus 1 is a one-to-one function find f inverse of x. Are you guys okay if I don't write step 1, step 2, step 3? Okay. Whew, thanks. So the first thing we're going to do is we're going to change this to what? Y. So change this to y. So y equals 2x plus 1 over x minus 1. Sorry, the TV's lagging. Okay. Then we're going to switch x and y. So this is new. Okay. Normally there's only one x and one y, but you guys see how we have two x's. Okay, so what this means is in this step, everywhere you see an x, change it to y. Everywhere you see a y, change it to an x. So instead of x on top, x on the bottom, it's going to be x is equal to 2y plus 1 over y minus 1. Okay. Is everybody cool with that? Now here's the strategy for this. We want to get y by itself, right? I have two y's on the right side, one of them on top, one of them on the bottom. So I want to get rid of the y on the bottom. So what I could do is multiply both sides by the denominator, y minus 1. By doing that, this will cancel. I'm going to distribute the x into both pieces. So I'm going to get x times y is xy. Negative 1 times x is negative x. That's equal to 2y plus 1. Okay, does everybody follow me? Now this looks a little weird. Remember, what's our goal? What do we want by itself? Don't we want y by itself? So do you guys see how we have a y on this side and we have a y on this side? I need to get all the y's on one side and everything that's not a y on the other side. So I'm going to subtract 1 from both sides. And then this will cancel. And I'm also going to subtract xy from both sides. So these cancel. So by doing that, I'm left with negative x minus 1 is equal to 2y minus xy. Is everybody okay? So here's a question to you guys. How do I get y by itself? We're going to divide, but factor. Good, because they both have a y in common. Does that make sense? So because they both have a y, I can factor out the y. Okay? So negative x minus 1 is equal to y times 2 minus x. And then, good, Alex, we're going to divide. So divide both sides by 2 minus x. This cancels. So we get y equals negative x minus 1 divided by 2 minus x, which means that f inverse of x is equal to negative x minus 1 all over 2 minus x.